All right, welcome to this explainer. It's an image that has literally captivated the world for over a century now. The RMS Titanic, a shattered giant resting 2.5 miles down in the pitch black of the Atlantic Ocean. It is, without a doubt, the most famous shipwreck in human history. And it's this enduring mystery that just completely continues to spark our collective imagination. Think about it. We have mapped the entire debris field. We've sent high-definition cameras down there to capture every single rusted rivet. We've sent specialized submarines down. We even know exactly where the grand staircase used to be. So that raises a really obvious question. Why hasn't anyone just attached some massive cables, hauled the whole thing up to the surface, and turned it into the ultimate museum? Okay, let's dive into this. Section 1. The crushing deep sea pressure, 12,500 feet below. Right, so the answer to our question really has to start with the brutal, totally unforgiving physical reality of the deep ocean. This is a realm where our wild human imagination violently collides with cold, hard physics. At that incredible depth, the physical state of the ocean is defined by one terrifying metric. The water pressure down there sits at a crushing 6,000 pounds per square inch. To really put that into perspective, imagine the feeling of just standing on a sunny beach right now at normal atmospheric pressure. Okay, now multiply that invisible weight pressing against your skin by 400. At the bottom of the ocean, the fundamental physical properties of matter completely shift. A standard submarine hull, it would instantly crumple like an empty soda can in a vise. The deep-sea pressure absolutely alters how materials, even thick steel, behave. And for explorers and tourists who actually seek to witness the wreck, well, the environment is lethally unforgiving. In June of 2023, the world was solemnly reminded of this with the very tragic fate of the Titan submersible. Under that 6,000 psi pressure, the vessel's carbon fiber hull collapsed in a literal fraction of a second, just reducing it to fragments. That is exactly what the deep ocean does to modern purpose-built vessels. So try to imagine rigging complex cables to a brittle century-old shipwreck in that exact same environment. It's wild. Section 2. The impossible weight problem, engineering against reality. Because see, even if you could somehow magically solve that lethal pressure problem, you immediately hit a secondary, completely insurmountable engineering hurdle, and that is sheer mass. The Titanic originally displaced over 52,000 tons of water. To wrap your head around that staggering number, lifting the Titanic would be the equivalent of trying to deadlift roughly 36,000 cars all at once, straight up from the bottom of the ocean. So the crucial point is that you aren't just lifting one solid, heavy object. The ship completely tore in half as it sank, right? The bow and the stern are separated by a massive 2,000 feet of seabed. From a pure engineering perspective, if you sit down and calculate the lifting force required to overcome the heavy suction of the deep-sea mud, while somehow maintaining whatever structural integrity the hull has left, you end up with a physically impossible number. No crane, no cable on Earth exists with the required tensile strength. Plus, after a century of extreme saltwater corrosion, the steel is so weak that applying any upward force would cause the hull to instantly shatter. You wouldn't be pulling up a ship, you'd just be pulling up clouds of rust. Section 3. Wild plans and failed rescues. Hubris versus physics. But look, despite these absolute physical impossibilities, the sheer allure of the Titanic has sparked a century of wildly entertaining, albeit deeply flawed, salvage proposals. It's basically a true story of human hubris versus physics. You have to look at the sheer creativity behind some of these ideas. Someone actually proposed filling the entire wreck with millions of ping pong balls to float it to the surface. Clever on paper, sure, but at 6,000 psi, every single one of those balls would be crushed flat instantly. Other people suggested injecting thousands of tons of petroleum jelly for buoyancy, or, get this, using 500,000 tons of liquid nitrogen to encase the entire ship in a giant block of ice. No way, right? Naturally, deep-sea physics renders every single one of these completely useless. And, of course, we have to mention Clive Cussler's famous 1976 novel, Raise the Titanic. In the book, they cleverly patch the hull and blow it full of compressed air, sending the entire ship rocketing up to the surface like a submarine. It's an absolutely incredible cinematic image. But, again, physically impossible. You cannot patch a shattered, heavily corroded ship that's in two pieces. And, more importantly, pumping compressed air at that extreme depth requires internal pressures that would completely blow apart whatever brittle steel is actually left down there. Section 4. Raising the Big Piece, a 15-ton reality check.
If you really want to understand the true, grinding, logistical nightmare of salvaging the Titanic, we just need to look at the one time somebody actually managed to lift a tiny fragment of its outer hull.
They affectionately called it the Big Piece. It's a 15-ton chunk of the starboard side that was discovered back in 1994. Now, recovering just this tiny piece required a massive flotilla and insane logistics. In 1996, they almost had it to the surface. They were so close. And then a sudden hurricane swept through, completely snapping the heavy synthetic cables and sending the steel plummeting straight back down into the abyss. They finally succeeded with upgraded equipment a couple years later, in 1998. It took millions of dollars, incredibly complex logistics, and sheer luck to lift just 15 tons. Remember, the whole ship is 52,000 tons. Section 5. The iron-eating Titanic bacteria. A microscopic dismantling. Because while we humans sit around debating cables and cranes, biology is quietly taking matters into its own hands. The Titanic isn't just rusting away, it is actively being eaten alive. In 2010, scientists actually discovered a completely unique salt-loving species of bacteria living on the wreck. They appropriately named it Halomonas titanicae. This microscopic force literally consumes the ship's iron. It metabolizes the steel and leaves behind these highly fragile, icicle-like tubes called rusticles. It's wild. If a submersible simply brushes against one of these biological formations, it instantly crumbles into a fine dust, taking a piece of the Titanic away with it forever.
And this brilliantly illustrates a really tragic chronological calendar of the ship's decay. Back in the 1980s, the deck features were clearly visible to explorers. Today, the ship is losing hundreds of pounds of iron every single day. The weakened decks are actively collapsing right now under their own weight. At this rapid rate, researchers estimate the wreck will be completely gone in 20 to 30 years. It's just going to leave behind nothing but a rusty stain on the ocean floor.
Section 6. A legally protected deep grave, the human cost. Yet, as we step back beyond all the impossible engineering and the aggressive biological decay we've talked about, there is a much deeper, far more solemn reason the Titanic remains on the seafloor. Ultimately, we have to remember, it is a mass grave. Looking at this purely from a legal perspective, the site is now heavily shielded by international jurisprudence. In 2012, which was exactly 100 years after the sinking, the UN officially designated it a protected cultural heritage site. Furthermore, a 2019 treaty between the US and the UK established incredibly strict statutory regulations regarding any visitation or removal of artifacts. So today, international maritime law ensures the wreckage is treated with the exact same strict jurisdiction and inviolable respect as a terrestrial cemetery. Because when you really view it through the eyes of the families left behind, all those loud engineering debates feel incredibly hollow. The ocean and the marine organisms consumed the physical bodies of the 1,500 victims long, long ago. But the chemicals used to tan leather actually naturally repel sea life. So today, resting quietly out there on the dark sediment, in the exact spots where passengers fell, are pairs of leather shoes. It is a stark, truly heartbreaking visual of profound human loss. Each one of those pairs of shoes represents a whole universe of personal tragedy. There were workers down there seeking a better life and families who literally sold everything they had to buy a ticket. Take Manuel Uruchutu. He was a Mexican lawyer who sent his mother a postcard of the magnificent ship on the very day he boarded, promising to visit her the moment he returned home. She never saw him again. His story, just like so many thousands of others, is forever tangled in that settling steel. So I guess the real answer to our initial question is pretty layered. We physically couldn't raise the Titanic if we tried, and morally, we probably shouldn't. As that Halomonas bacteria finishes its work and the ocean slowly reclaims the steel piece by piece, we kind of have to ask ourselves, for the 1,500 souls resting out there in the abyss, isn't the quiet, undisturbed deep the most fitting end of all?